So, hello everybody. Welcome to episode 2 of Building with Blitz. We're going to start off with conceptual content of loading. So, this is loading 101. As we get more advanced in the topics, it'll be like loading 201 and loading 301, kind of diving into certain requirements. But so far, this will be a conceptual video, and I think the way that I can structure this to be a little bit more efficient is keep 101 and 201, 301, for example, as conceptual videos, and then like 102 and 103 loading would be example problems for different types, and not just for but like for mechanics or torsion 101, for example, and then 102 would be a example problem. So let's go ahead and get started. So why should we really even care about loading? It it tells the story of the structure or your design. So different types of buildings have different load designations. Where like schools, bridges, hospitals, even stadiums, they all serve a purpose, and that purpose is really kind of defined by the load designation that you as a designer are going to place on certain on the system. So a way to think about it, because you start the design process with a load analysis typically. So you first want to determine how to tear your structure down. And this is done by the analysis. And so the way that I visualize it to kind of keep it interesting for myself is the load is the bad guy. You know, it's trying to break down your structure. It's trying to tear down your bridge or whatever. And then the next phase of the design process is where you're trying to figure out how to, fight back against the bad guy per se, to design your structure to be able to withstand what you've assigned it to tear down. And so there's multiple types of loading. Given that this is a 101 video, it's going to be very kind of broad in concept. So we have dead load, which we'll kind of dive into these later on. So we have dead load, live load. Lateral load is, I gave an example of wind and seismic, even though wind and seismic can also be gravity load. Well, not gravity load, but vertical load. But an easy way to visualize both of these forces primarily is as lateral loading. And then we have other types, and many more outlined in the codes, whether it be AASHTO or ASCE 7. We have vehicle, rain, snow, ice, impact, fatigue. These, again, are just examples of how you as an engineer are going to want to, quote, tear down your structure before you start the design. So to move into a little bit more in depth, dead load, if you consider something a dead load, that means it's not moving. So a good way to visualize that is a floor slab. Floor slabs, it's not going to, get up and walk away, and neither are walls or architectural finishes. Like most of the time, whether this be, a ceiling tile or a type of like architectural floor, like some type of tile, for instance, you would consider that to be a dead load. And so kind of the codes that you're going to use as a designer or throughout studying for licensure exams or even in school, ASCE 7 is the broad kind of code book. ASCE 722 is the more recent iteration of this. It's going to be chapter 3. And so ASCE 7 is broken up, and we'll dive into this later with kind of the code breakdowns. There's 2 books, the provisions and the commentary. The provisions tell you kind of what to do with the dead load, And the commentary gives you a table of common like dead loads, which is pretty convenient when you want to say, hey, how much do I need to take into account for a MEP overhead to design this beam? So governing over that is the IBC, that's the International Building Code. Chapter 16, Section 6. Chapter 16 is the structural analysis or design chapter. So you'll use that in addition to ASCE 7 if you want to design a building. AASHTO follows pretty close for dead load because, a beam is a beam, whether it's holding up a bridge or holding up a car or holding up, a printer. You're going to consider both of those to be like a component self-weight, which is a dead load, which is outlined in AASHTO as well. Slightly different, but overall conceptually the same. So live loading, this is kind of interesting because you want to consider live loading as it can move. So this could be like for a school, for instance, a classroom live loading is, I want to say 40 pounds per square foot outlined by ASCE 722. But what that contains is students or desks and other things that would go on in a classroom that can move. So the big kicker here, really, and this goes for live roof loading as well, is it can be reduced because that reduction can be taken over the tributary area of the member, and certain probabilities that, if you have a 600 square foot tributary area, for example, the odds of all 600 square feet being loaded to 40 pounds per square foot, if we're still going back to the school example, is pretty low. So you can reduce that based on the area and the type of member that you have, which we'll dive into later. But a good way to visualize the live loading is yourself. This could be occupancy load. Cars, I gave the caveat here of like parking garages, because cars for bridges are moving loads. But for a parking garage, you're going to take the weight of the car being parked as a live load. And going back to the school desks or other, this could be for office building or whatever. So another caveat, and this was partition loading, kind of the ninja of ASCE 7. I outlined this because partition loading cannot be reduced the majority of the time, unless you have some really heavy live loading. I think over 100 PSF outlined. So this would be like a parking garage, but you're not going to have partitions in a parking garage, so you wouldn't even add that there. But just for example, partition loading, you want to take as 15 pounds per square foot, and this is outlined in ASCE 7, Chapter 4. And so you take the live load and you can reduce everything else but the partition load, which is important to note for licensure examinations and even in practice, because you might have a question that is, what is the live load for a 200 square foot office kind of area? So you would have 50 pounds per square foot taken out of the table, in addition to the 15 pounds per square foot from the partition loading. You may be able to reduce kind of the 50 pounds, but you have to keep the 15 as it says. So in the code, ASCE 7, Chapter 4, both provisions and commentary. IBC Chapter 16, again, Section 7, you're going to get the same or pretty close to the same table from ASCE 7 as you will in IBC. But there might be some hierarchies that you need to consider depending on what case you have. And then AASHTO, this is where, like I was saying in the parking garage, AASHTO live loading is a little bit more in depth because you're dealing with moving loads, which we can get into later. But for right now, just know that live loading for bridges is most of the time going to be a moving load. So for lateral loading, this can get very complicated, as noted kind of on the bottom bullet point. Wind and seismic is difficult. That is why I jokingly put it's half of ASC 7 is seismic, and then the other half of ASC 7 is wind. That's because the majority of the chapters in that provision are wind and seismic, whether it be one or the other. And honestly, I mean, there's experts in, just seismic loading or just wind loading. It can be very complicated. And so I think we'll have to have a separate kind of video series for each of those. And this can be location dependent. For example, like in California, you're going to have a higher seismic load, just because of the faults. Even in Memphis, actually is a pretty high seismic area, as far as the United States. And then Oklahoma, because it's flat and there's not really many vertical obstructions, you're going to have a higher wind force than, say, a more urban area, especially also down in the coast of Florida area. I have a buddy who works with crane designs, and Florida is always kind of a booger for wind forces because it can dominate a lot of the loading criteria down on the coast. So other loading. This is kind of vehicle loading. Live loading is you're going to get a lot of those provisions in AASHTO or crane loading, and this is outlined in ASC 7 Chapter 4 with the live load. Crane or monorail loading is considered a live load, so you have to kind of be careful there. Rain loading, this, there's combinations that use rain load, but it doesn't really. I have yet to see much. I don't really work in rainy areas per se, but I've yet to really see much in as the way of rain loading, and that's in ASC 7 Chapter 8. Snow loading. I'm in the Southeast. So a lot of things that I've seen don't really take into account snow loading, just because we don't get a lot of snow. But that's in Chapter 7. Ice loading is Chapter 10, and there's AASHTO equivalents for all of these, but I want to say you can interchange some cases with ASC 7. It just kind of depends. And then impact loading. This is mostly thinking about bridges. Like if you have a bridge going over water, the columns that are underwater or within the water space, you'll consider impact loading for like sheet ice, boats. We've seen what happens, when boats crash into bridges. So you do have to take that into account. Fatigue loading, this can get pretty in depth once you start talking about certain material, like steel. AISC, 360 has fatigue loading provisions, as well as overall like building codes. So once you start getting into material specific designs, like concrete behaves differently than steel when it comes to fatigue loading. So you do have to take that into consideration. And so all that to say, there's a lot more, and you can be very niche in kind of your study or designation for some of these criteria. It really just all depends, and I'll kind of say that a lot as we do these videos. The answer a lot of time is it depends, because it really does. So now that we have our loading designation, what do we do with that? We want to try and, like I said before, the load is the bad guy. So we need to get that out of the structure in the most efficient way possible. So this picture here is from a project that I worked on. It's a very elementary load path diagram. Um, so this shows how we get it out of the structure. And that's obviously through like beams and girders and then columns. But we want to get it into the ground and dissipate that away, that energy away from the structure. So logically, we say we're standing on a second story floor. So our weight is going to go to the floor, from the floor distributed to a beam. From a beam, it's going to go to a girder to column, which is kind of shown here. So the girder is going to take it to the column. The column's going to take it straight down to the foundation, where I say goodbye, but the foundation is going to dissipate that into the soil, which is where we get bearing capacity in foundations, because that's the soil is really taking all the energy away from the building. Very rough analogy, but it works. So I think that's all we're going to cover for this episode. The next episode of 201, we're going to get a little bit more advanced into tributary area and widths. This is for the analysis of particular members. Load pathing concepts. There are certain ways. I know I just gave that diagram example, but you can get a little bit more in depth with load pathing for gravity and lateral loads. Live load reduction. What kind of this topic means for FE and PE exam, because I know the PE civil structural exam has an entire section dedicated to load analysis. And the PE has it, or the FE has it a little bit, but it's still important to note. And then kind of quick, not necessarily cheats because it's not cheating, but quick use cases for everyday use, whether that be in practice or in school. So I thank you guys for watching. And again, as stated in kind of the overview episode, if you have any specific topic that you want to see, please let me know and we can get that content going. So I appreciate y'all and have a good day.